I understand they are complicated, so they take some time. When is our quiz on piecewise functions? Say it again. It is next Tuesday. It is next Tuesday, which means we are going to take a checkpoint. I actually want to start the checkpoint tomorrow because some of us are great with piecewise functions and we'll be fine and we'll pass it in 2 seconds. And let's face it, some of us, piecewise are a struggle. I'm with you, piecewise is a struggle. So it might take us a little while to pass through the checkpoint. So we're going to start it tomorrow. That way if we need to wrap it on up on Monday, we can. Let's see. I think I said your homework was due when? Monday. Your homework's due Monday, and I have some people who have already started it. You're going to have some time during class today and tomorrow to work on that. Let's go over these math workshops, and then we'll go over, we are going to practice graphing one more problem from your piecewise function doodle notes if you want to get those out. I do want to make sure we're on the same page with that. So get out your doodle notes. We are going to graph one more. Okay, as for the math workshop, we have a graph, and we are supposed to write a description of this graph, and there are lots of different responses that would be perfectly acceptable. So you want to have a description for this graph seen on the screen. A description for what's going on the screen. In your description, what we're looking for is, are you going to describe the 3 different parts of this graph? Yes, dear. Okay, but they didn't actually run 3 meters because they started off at 1 meter. They technically ran 2 meters, but yes. And you're being very specific. You could be more general than that if you wanted to be. For how long? 3 seconds.
That's 1, 2, 3, 4, 5.
Yeah.
And then 5 of the rest.
Okay, so I heard bits and pieces of it all, and we're going to use bits and pieces of everyone so everybody can have a point. Yeah, I know. I don't know. You think it's a woo, and let me warn you, Table 1 has been jinxed all day long. First period and second period. It's the third period. I'm challenging you. Table 1, do not lose your point. Yes, dear. You didn't get a slip? Okay, there's one up here in this. Drea knows where they are. She can show you. Okay, so I agree. We're basically going to write 3 different sentences. I'm going to write a sentence about the first part. I'm going to write a sentence about that second part, and I'm going to write a sentence about that last part. 3 different sentences. Now, some people are very picky with their sentences. Landon was starting off very picky with his sentence. He was saying, between 0 and 2 seconds, they were walking and increased 2 meters. Like, he was very specific with it. I'm not going to be that specific. I'm lazy today, so I'm being a little more generic. I think I might say, I'll do an abbreviation of his. I'm going to do it shorter, though. From, if I can spell today, from 0 to 2 seconds. We'll assume it was a he. It didn't tell us. He walked 2 meters. I agree with that. Landon said something about from 2 to 7 he rested. Well, actually, he didn't say 2 to 7 at first. Thankfully, DJ and some others helped him figure that out. So we'll say he rested for 5 seconds. Or maybe Drea wants to write out he rested from 2 to 7 seconds. I don't really care how she writes this out. Again, English gets to be your own thing. So if you want to have different sentences than me, that is fine. And then for the last couple of seconds, from 7 to 10 seconds, he again walked 2 meters. Now, you and I could improve our responses. We could be more technical, because when he first left, I'm going to put he walked back 2 meters as well, because someone else said that. He is returning to his starting position. I think it was you, Andrew. He is returning to his starting position. So us referencing that would be good. So if we added the word he walked back, that would be good, because when he, in that last little bit, he is returning to wherever he started, apparently 1 meter away from something. If we wanted to be more specific about how from 0 to 2 seconds he was walking at a faster rate than he was between 7 to 10, that would be something nice for us to notice. But it didn't say, really. There should have been more parameters. I think what we've done is sufficient. As long as you're putting seconds and meters in your answer, showing that you could read that from the graph. That would be what they're focusing on. And then they trick a lot of people, because from 2 to 7, some people would say he walked at a constant rate because it's a straight line. We need to understand that if he was walking at a constant rate, then that graph would be changing. From 2 to 7, he's technically just standing there, or sitting there, or whatever. He's not moving. And then this whole thing is really dumb, because why do we really care about this guy's walk from 0 to 10 seconds? Who cares about a 10-second walk? So silly. So really silly. But maybe, I mean, last period we had more excitement going on than snapping, because, you know, we had the drill going on. So I joked maybe this was a terrible joke, but I joked that maybe this was like the intruder's path, so we needed to pay attention to it so we could know where he was coming from. So, anyway. Okay, moving on to the next one. Kimmy thinks that this graph and this table go together. They're the same linear representation. Carla disagrees. Who is correct? Kimmy is correct. And then, of course, the most important part, it says explain your reasoning. So if you can explain, you can get your point. I think there are 2 different ways to explain this. Yes, dear? Yes.
Because when you look at the X and Y chart, all of the points line up with where they connect on the graph.
Okay, so there are 2 different arguments you could take, and Xavier took one of them, and his group gets a point. One argument you could take is that the points match. 0, -1, 0, -1. They matched. 1, 1, that matches. 2, 3, that matches. 3, 5, it looks like it was about to match. That arrow seems to imply it. So, yes, one argument you could take is that the points match. However, I'm hoping you take a different argument just based off what we've been doing lately. Brady, yes, dear.
I have a same slope.
That's what I'm hoping for. I'm hoping we're somehow going to talk about slope, or what was that other term we used?
Rate of change.
Rate of change. And table 3 gets a point. So I'm hoping because of what we just did on our last test, instead you argued rate of change, or, Lord Jesus, miscomprehension, slope. I'm hoping you argued that they had the same rate of change or slope. So if we notice on this one, it's increasing by what in the x values? It's increasing by 1. Thank you, table 5. You can have a point. It was not table 5. It was table 6, wasn't it? Who was it? Who said 1? It was Lyric? Oh, okay. It was Lyric. Lyric, you can have a point. I thought it was further away from me than Lyric. And then the y values are increasing by 2. Caitlin, was that you? Thank you. And Caitlin's group can have a point. And so what would the slope be then? What would the rate of change be then from this table? 2, which is 2 over 1, which is 2. Thank you, Abby Race. You're the one I heard first. So you can have a point for that. So the rate of change is 2. So what we're seeing is, does this graph also have a slope of 2? Well, if we go to that inner step and we start counting, did it go up 2 over 1, up 2 over 1, up 2 over 1? Yes, it did. So we could argue that the rate of change or their slope match. No, Xavier is completely correct. But you can see how from your last test, this is kind of the direction I was thinking in my brain instead. Okay, are there any questions about our 2 math workshops? Then let's do your piecewise doodle notes. We flip to the back of them. I want to do the top one, and I want some help with it. Oh, like this. Okay, so, and before we even go crazy and start doing that, let's make a list of the stuff I want from you, of what I'm expecting. Okay, so you know you have a quiz on Piecewise next Tuesday. So far we've done evaluating piecewise functions, and that is why I need to see, if I haven't already, I need to see your completed Homer-Simpson puzzle. So if I haven't already seen your Homer-Simpson puzzle, when I get done rambling, you need to finish that, and then I need to see it. That way you can get your points for it, because it is a grade. So that's the first thing I need from you. The second thing I need you to be working on is about what you think. So, top this. I need you to be working on your homework. As you recall, it is page 23 and 25 of your notes. Page 23, Xavier can do pretty quickly. It's just more evaluating practice. Page 25, however, is going to take Xavier a long time because he has to graph. It was 16, we took off 3. He has to graph 13 piecewise functions. He has to graph 13 different ones. 13 of them. So you can see there are a lot of problems. So needless to say, when he's got his Homer-Simpson done, he really ought to get on the graphing. It's not due till Monday, but Xavier does not want to spend his weekend graphing piecewise. So I'm telling him between today and tomorrow, surely he can get those 13 graphs. I have tiny, ugly graph paper in the bottom third drawer. If you would like a prettier piece, if you ask me when I get done rambling, I will find you one. Okay, so that's what I'm hoping. And then what's going to make Travis and everyone else super happy is what I'm going to write on 3. Is that the other puzzle page are bonus. The other puzzles are bonus. Let me be more specific about those. The Godzilla is a little difficult because you have to actually look at the graph, see what the Y value is to figure out how to evaluate it. So you're actually supposed to look at the graph rather than plug stuff in. So that's why Godzilla takes time. If I were you and I was trying to pick which one for bonus, I would do the horse one. But the horse one is more difficult than you think because it's just supposed to be you're given a piecewise function and you match it to a graph. Matching sounds easy. No, it's not, because sadly some of them look like the exact same thing. It'll be like x less than 3, and the other one will be x less than or equal to 3. Like they're the exact same problem, and the little tiny difference is the less than equal to. So if you want to do it, you can. The horse one's feasible, but it's going to take some time and some patience. So just so you know, you do not have to do that second puzzle page. I passed it out yesterday. It is going to be just bonus. Okay. So are there any questions about what I'm expecting from you after I graph one more problem? Okay. I think, in my mind, in my soul, I think that Mason, when he's on Earth, he can evaluate a piecewise function. I'm just not sure he can graph it, so I want to go over it one last time, and I'm needing some help. We had 3 steps. Our first step was to draw fences. And sometimes we won't have to draw. In fact, we'll do both of them. We can do both at once. We're that good. Maybe we won't. I don't know. If we have to draw a fence, where would we put our fence at on example 1? -1 and 2. Because -1 and 2 are where those issues are happening. And that's how your group gets a point. So -1 has a fence and 2 has a fence. Lately, I've been doing my fences solid to make sure Caitlin could see them. I shouldn't do that, should I? Fences are supposed to be, dotted. Thank you, table 4. You can have your point. They're supposed to be dotted. So we drew our fences. My next step is to graph, but I always graph in pencil. Now, Mr. Moore do not tell him I said this, but sometimes he's a little smarter than me. So what he explained to his people is that, for instance, on our problem, those 3 different graphs, if you need to put y equals and write the 3 different things, you can. So we're going to graph y equals x plus 7. We're going to graph y equals 3x plus 1. And we're going to graph y equals x. And if it makes more sense to you to write them out, that's okay. I just thought you kind of understood. But that's my bad. Yes, dear.
Okay, I'm going to feel really stupid if this is just part of the line, but up there where you have the fences, is that on record? Is that supposed to be a 1 under there, or a second, or part of the line? Right there it is.
Oh, it was just part of the line. This one, but this fence was at -1. This fence was at 2. No.
Okay, just making sure.
No.
I was about to ask why you had.
Okay. And then Mr. Moore is a little smarter than me in that he explains to his people, there's no need. You know how I like to erase stuff? Because I think that's fun. Maybe Andrew doesn't like to erase. You don't have to. You're smart enough by now to realize, P.S., this one's going to be to the left side of the fence. This one's going to be between the 2 fences, the middle. And this one's going to be to the right side of the fence. So if you don't want to draw it, like you're smart enough to realize, hey, I don't need that guy over here, and you don't draw it over there, I'm not going to be mad. This is just how I do things. Okay, so if I was graphing and I graph y equals x plus 7, can someone in English tell me how to graph that? Okay, so I go to 7. 1, 2, 3, 4, 5, 6, 7. I put my point. Up one into the left one?
Oh, up one to the right.
Because it's a positive slope. Yep. Okay, that's fine. Landon and Mason's group get a point. Mason, wasn't that your voice?
Yes, ma'am.
Okay, your group gets a point. Okay, so I graphed this line, y equals x plus 7. And I did it kind of ugly and in a hurry. But you and I both know that I don't actually need this graph anywhere but to the left of that fence. So I can erase it over here. I don't need it. I don't need it until we get to that fence. And then my graph's really ugly, but it'll be okay. I really don't. I'm not being that picky today. Okay, do I fill in my circle? Because that step 3 is about those fence points.
Yes, ma'am.
Why?
Because it's less than.
Since it is less than or equal to, we actually end up filling in that circle. Landon, your group can have a point, but don't answer anymore for me. Okay, so we graphed this guy. Are there any questions about this? Does anyone have any questions about the left guy? Yes. Okay. So one thing I want to point out, and that's what happened first period, and Landon did not say this, so I did exactly what Landon said, which I appreciate. Landon said, put the 7 on the y-axis. There was someone in first period who put the 7 on one of the fences.
Yeah.
It's still y equals mx plus b. The b still goes on that y-axis. We're not going to do anything weird with those fences. All we're doing is, if our line happens to touch at the fence, that's when we start questioning things. But we do not start our line on the fence. That is not a no. We're not going to start doing that.
So,
Y equals x plus 7. You put your point at 7 on the y-axis, then up 1 over 1, up 1 over 1. They were trying to put their point at 7 on the fence line, rather than 7 on the y-axis.
okay, so we just put our 7 on the y.
Yeah, it's just like graphing like usual. We're only using those fences if our graph happens to touch the fence. That's when we start asking, like, it's kind of like if Eric and I were neighbors, if his stuff's in my yard, whose yard is it? Like, where do we decide the line is between us? And where, who owns it? Who's going to cut the grass right on the line? Okay, so we graphed the first guy, and now we got to, Andrew, you had a question before I move on. You didn't have a question. Okay, so we got to graph the middle guy, 3x plus 1. So we go to 1. And then our slope is 3x, so up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. But hey, Xavier's smart enough by now, he realizes, Miss Compton, that last point was stupid. You knew it was between the 2 fences. That's outside the 2 fences. You didn't have to put that. Good for him. 1, 2, 3, down 1. 1, 2, 3. I don't know, maybe I like erasing.
You do.
So again, I realize below this fence is silly. Above this fence is silly. I really just need it between the 2 fences. So I'm going to make this guy pink. And I'm going to put it in between. And then I've got to ask myself, because step 3 is about those points, do I actually fill in those pink circles or do I leave them open? And I leave them open because why?
It's not equal.
Yes, it's just less than. So we're going to leave it open. Okay, and then we get to our last one, which is y equals x. So for this very last guy, I'll graph him, let's say, in blue. So really, you and I realize that's y equals x plus 0. So we put our intercept at 0. And then we count up 1 over 1, up 1 over 1, up 1 over 1. And I could go down, but I'm starting to get smart enough. I realize, P.S., I'm only going to want them on the right side. So I'm not going to waste all my time this time. So I've got this last guy. I really only want him till the fence. So anywhere below the fence, I'm going to erase him. So here he is, and you and I have to argue about this fence point. Are we going to fill it in, or are we not going to fill it in? Because it's equal to. Okay. We are going to fill it in because it's greater than or equal to. Are there any questions about this, or are you starting to get bored with it like me? Are there any questions about this? Okay, you realize sometimes life is super easy, so I'm going to make up something real fast. This is not at all true. Actually, I see people still writing, so. You and I have been doing 3 ones over and over and over and over again. We've been doing 3 ones. There's a left, there's a middle, there's a right. A left, a middle, a right. You know those are the harder ones, right? Sometimes there's just 2. Sometimes you only have 1 neighbor. Sometimes, and this is not true for this problem, I'm just making it up. Sometimes you only have 1 neighbor, and you're fighting over the 1 fence. You're fighting over the 1 fence, and maybe this guy exists here, and maybe this guy is down here. Sometimes you only have 2 guys. You don't always have a 3-guy problem. Sometimes, like on this one, it's just a 2-guy problem. And you only have 1 fence if it's a 2-guy problem. Their only issue is at -7. Did I put my thing at -7? Heck no. I wish I had. I didn't. Okay, are there any major issues? Okay, I'm going to put that list on the board again. I pray I see your Homer Simpson before you leave the room. I do intend to type in the zeros for that. I would start my graphing homework. If you want nice graphing paper, ask me.